Hi, my name's Mike Zephyr, and I'm an associate professor at the University of Melbourne in the Faculty of Business and Economics, and a convener with the Melbourne Center for Data Science. And today we have a talk for QMNET, the Quantitative Methods Network here at the University of Melbourne. And we have an esteemed colleague, Anissa Tanweer from the University of Washington, here to talk to us about data science, meta expertise, or interstitial craft. This is a very exciting talk and speaker. I'm so happy. Thank you so much for coming. Let me just say a few words about you, Anissa, before we get started here. Anissa is a research scientist at the University of Washington's eScience Institute, which is how I found you. Looking through what is actually a very well put together website. I highly recommend people go check it out. As an ethnographer focused on the rise of academic data science, she's interested in understanding and shaping emergent data science practices and norms. In particular, she focuses on efforts to harness data for social benefit and has both studied and helped develop the eScience Institute's annual Data Science for Social Good program. Dr. Tanweer's dissertation, Data Science of the Social, How the Field is Responding to Ethical Crisis and Spreading Across Sectors, won the University of Washington's 2018 Distinguished Dissertation Award in the Social Sciences. And you have a number of positions, including with the eScience Institute, including being a program chair and I think deputy director. Is that true? Oh no, I'm wrong. Sorry. But thank you so much for coming, and please feel free to take it away with James, who's also here. Thanks, James, for coming.
Yeah, great. Thank you so much for having us. We're really excited to be able to be part of this community from so far away. And when I was, exchanging emails with Mike and trying to figure out what I might talk about, he said people in the QMNET group are often asked what data science is. And I just so happened to be working on a paper with James about that very thing at the moment. So I thought that might be the perfect thing to talk about. And so this is work that is being written in collaboration with Dr. James Steinhoff, who's also on the call today. And after the presentation, he'll join the Q&A and discussion session. And so you'll hear from him at that point. And I have about 35, 40 minutes of content, I think, to present. So hopefully that will leave plenty of time for some good discussion at the end. So let me figure out how to advance my screen. Anyway, as I'm sure everybody in this group is already aware, there are many different definitions of data science in circulation in the world. And they run the gamut from humorous, data science is statistics on a Mac, to pithy, data science is the science of data, to meta, data science is the study of extracting value from data, to almost koan-like, data science is what data scientists do. I actually love this definition as an ethnographer. I have to wholeheartedly agree with that one. To really expansive. So data science is an umbrella term to describe the entire complex and multi-step processes used to extract value from data. But I'm an interpretivist qualitative social scientist. And that means when I think about the question, what is data science? I don't really see it as my job to come up with a definitive answer. So instead, I'm interested in finding patterns and salient variations in how people make sense of their experiences with data science. And so what I'm going to present today is based on ethnographic research that was conducted between 2014 and 2019 within the data science community at the University of Washington. And just to give you a little bit of background on that community, it centers around the eScience Institute, which is an organization that's been around since 2008. So that was kind of before the term data science was really in vogue, which is why its name sounds a little fuddy-duddy to us today. But as people at eScience sometimes like to say, they've been doing data science since before it was cool. Anyway, the organization has been around for almost 10 years, but it was about 6 years ago that it got something of a steroidal injection in the form of a grant from two private philanthropies, the Robert and Betty Moore Foundation and the Alfred P. Sloan Foundation. And the University of California, Berkeley, New York University, and the University of Washington received this joint grant that was intended to establish what they were calling the data science environments. So the idea was to sort of broadly foster the conditions that would support data intensive science. And that was anything from formal education offerings to informal training to hiring innovative faculty, creating collaborative spaces, developing open source tools. It kind of, it entailed a lot of different activities. And so for the sake of time, I'm not going to dwell too much on kind of providing context and background on this study, but I just want to make two quick important points. One is that our community of study sees itself working on data science for science, as opposed to data science for business applications, for example. And another thing is that each university that was part of the Moore Sloan Data Science Environments Grant all ended up doing something a little bit different. So even though there was a lot of dialogue and coordination across the universities, they all had kind of their own flavor and approach to data science. And at the University of Washington, there was a very intentional decision made from the get-go by the architects of the initiative that data science wouldn't become just another discipline at UW. And so I just want to acknowledge that, because it undoubtedly shapes our analysis and what we heard from people, and might make it rather unique to the context that we're looking at. So for those of you who may be less familiar with what ethnography means, ethnographers try to understand a community kind of both from the outside in and the inside out, so to speak. So we really get immersed in the community we're trying to study in order to understand the perspectives of members of that community. And we use a range of methods to do that, but the signature one is participant observation, which is kind of exactly what it sounds like. So it means simultaneously becoming a part of the community to some extent, but also retaining the mindset of an analyst. Participant observation is a little bit of a spectrum, though. And so when I started my field work back in 2014, I was still a graduate student, and I considered myself to be a little closer to the observer end of the spectrum. But over time, I got more and more involved in the community to the point where after I graduated, I accepted a full-time position at eScience. And so as of 2019, I haven't been collecting any new data, although I'm continuing to analyze data that I collected over the course of the preceding 5.5 years or so. Anyway, in addition to participant observation, ethnographers also conduct interviews, we analyze documents, we sometimes collect surveys, we do kind of, whatever it takes. And between 2014 and 2019, the team of ethnographers at UW conducted about 150 interviews. And in most of those, we started out by asking our research subjects, what does data science mean to you? And do you identify as a data scientist? And then why or why not? And so the analysis I'm going to present today is based primarily on the responses to those particular questions. And so for this paper, we've taken a constructivist grounded theory approach to analyzing that particular subset of interview questions. And then we're drawing on the participant observation field work to kind of interpret those responses and put the interviews into context. Because we're peddling in quotes, that's our data source. I'm just warning you that I'm going to be showing you quite a bit of text. And so I just want to apologize in advance that I know this doesn't make for the most visually stimulating of presentations. And I also want to acknowledge that this has been a collaborative process every step of the way. So it's based on fieldwork and interviews that were conducted with Britta Fiora-Gartland and Mara Jurek, both of whom are now researchers at Tableau. And data analysis was conducted with James, who I already introduced you to, and he and I are writing a paper based on this together. And I also want to say that we're kind of right in the middle of writing this. So we have our qualitative data analysis done, but we're still thinking about which literatures and theories and ideas we really want to be in deepest conversation with. And we're still thinking about the most important conclusions that we want to drive home. So it's not quite polished, but I think that makes it kind of the perfect time to share it and get feedback. So we're really looking forward to hearing your thoughts and ideas and critiques and any other things that you want to share with us in the discussion section. Okay, so going back to the question of what is data science? As I mentioned earlier, we're not really interested in coming up with a definitive answer to that question. Instead, we're interested in using people's responses to that question to understand certain things about data science as a phenomenon. So for example, what is its relationship to other fields? What qualities make it a cohesive pursuit or practice? What are the stakes involved in its emergence? And a lot of people directly involved in data science are asking and debating these very kinds of questions themselves. But among people like me who take data-intensive phenomena as their object of study, there's been less focus on these kinds of issues to date. So I tend to read and write in a couple interdisciplinary fields like science and technology studies and critical data studies. And there's a ton of really, really great and important work in those communities on the social and ethical and epistemological consequences of data-intensive technologies. But there's not a lot of empirical work on either the day-to-day practices that constitute data science or on the emergence and institutionalization of data science as a field. There's some work that looks at data-intensive approaches within particular fields. So I'm thinking of Sabina Leonelli's research on data-centric biology, for example, but not a lot that's taking data science as an object of study more broadly. An exception to that is recent work by David Rebus, Steve Slota, Andrew Hoffman, and Jeff Bowker, who have been really thinking about the emergence of data science and also the relationship between data science and other fields. So Rebus says that data science is experiencing a gold rush and a disciplinary turf war with computer science, statistics, mathematics, information science, and various collaborations with scientific, state, and industrial sectors, each making claims to the expertise, funding, and regulatory sphere of data science. And according to these scholars, data science is framed as a universal science, essential to all future sciences and beyond. Data science recognizes domains such as biology or astronomy, but it doesn't consider itself to be one of them. And universality is defined and architecturally materialized as this absence of specificity. So from this perspective, we can think of one of the qualities of data science as being that it's transcendent. So it's agnostic to specific contexts of domain applications. And they also observed that data science has no data of its own. It's a parasite characterized by emptiness and hunger. Data science connects to the domains via prospecting or the activities of discovering disordered or inaccessible data resources, thereafter to be reordered and rendered available to data scientific work. So we can think of data science as being appropriative from this perspective. It's a thing apart that kind of reaches into the domains to extract raw materials and advance itself. Then following from that, exploiting these disordered resources necessarily involves an ordering of that data according to the needs of data science. The very mention of systematic and scalable approaches to winnowing, curating, publishing, or processing data points to the fact that the work of universalizing in data science, that is of opening up domain resources and of making them available to engagement by data scientific approaches, is in fact a normative process of ordering according to certain data scientific conventions. So we can think of data science as having an impositional quality here. So it's rendering the data and questions of the domains legible to data science. So from the analysis of Rebus and Slota and their co-authors, we can distill three distinct but kind of mutually reinforcing characteristics of the universalizing data science. It's transcendent in its agnosticism for disciplinary context. It's appropriative in its prospecting for data from other domains. And it's impositional in its ordering of data and questions so that they become legible to data science tools and techniques. However, these authors also recognize that this universalizing vision for data science might go unrealized and even suggest that universality is likely to remain remote because even basic principles, definitions, and concepts show local variation while competing universals produce disordered noise even when other forms of locality are erased. So the universalizing nature of data science isn't firmly established yet, but it tends toward that direction. Now, this universalizing formulation of data science can indeed be found within our field site and among some of our research participants. But we found that it's typically expressed partially or equivocally. And for every expression of these characteristics, we found data science being framed as something else entirely. So rather than viewing data science as transcendent with regard to disciplinary contexts, many of our research participants described it as thoroughly grounded in specific applications and highly sensitive to the context of those applications. Rather than viewing data science as having an appropriative stance toward domain knowledge, they described a relational arrangement in which data science doesn't exist separate and apart from scientific domains, but rather emerges from collaborations between them. And rather than characterizing data science as playing this impositional role in ordering the domains to be legible to data science tools, they see data science as an adaptive practice of improvisation, customization, and exploration that results in bespoke tools. And so now I'm going to dive into the evidence for these perspectives in our field site. So the Transcendent View sees data science as relevant to all domains of knowledge, irrespective of any contextual specifics, including things like data provenance or a discipline's epistemic culture, prevailing norms, history, its current state of knowledge, et cetera. And a transcendent perspective of data science, I think, really informs the eScience Institute's whole kind of raison d'etre. And that's apparent in its tagline, which is advancing data-intensive discovery in all fields. And when talking about eScience, the organization's leadership will often emphasize what they call the Institute's neutrality on campus. So they're kind of implying that it rises above competition for prestige or resources that might exist between more traditional academic units. And eScience has positioned itself as a service organization that benefits the entire campus community by offering trainings and consultations and opportunities for collaboration. Because of that, it was able to secure dedicated funding from the university to support its operations through state funding as a public university. And that includes the maintenance of a core staff of non-faculty research scientists who are in what's a pretty unusual situation, at least at US-based universities, of having permanent salary lines rather than being in precarious soft money positions. And that unique status is at least in part premised on the organization's success at portraying data science as transcending disciplinary boundaries and being applicable to all disciplines on campus. And I'm mentioning these particular organizational arrangements here because they explicitly informed the perceptions of data science that were formed by some of our interviewees. So for example, the service activities of eScience contributed to this person who is an oceanography postdoc to their view of what data science is as something that sits apart from and is categorically different from scientific domains, yet is universally applicable to them. So this person says, I say this in a very non-pejorative way, but this idea that what eScience is providing is support services, right? I'm an oceanographer, and so 75% of my brain is oceanography, 15% is art, and 10% is databases, right? So I can go and find someone who's 75% of their brain is cloud computing and databases, or I can go and find someone in their Python and PCA or some statistical method. And I understand to these guys, that is their domain. But this idea that domain is the application space, just call it science. I mean, obviously people here have interests, whether it's astronomy or whatever it might be, but you're also a little bit application agnostic. I can come to Mariah or Annika with an oceanography problem or a demographics problem or whatever it may be, and there's some capacity for them to engage with it because it's just math or it's just Python or it's just statistics, whatever it may be. But that transcendent view coexists alongside a perspective that sees data science as actually quite deeply grounded in the idiosyncrasies of particular applications and contexts. So in this first quote here, when we asked, what does data science mean to you? They answered the question by contrasting their experience in the eScience incubator program with a previous attempt to reaching out to computer scientists. So they said, I've been trying to figure that out for a while. And I think the shortest explanation I could give is that when I have this big data problem, I first went to the computer science department and a couple different people there, and they weren't very interested in it. Then I went to eScience. Josh was very interested in it. I think to me, it's dealing with problems that have to do with big, messy data sets rather than computer science type topics. Sorry. All computers work with data. No matter what you're doing, it's working with data. It's just whether you're solving more theoretical problems that could have an application or whether you're solving real world messy data problems. So to this person, data science is distinctive for its engagement with practical details and specific applications, rather than being concerned with engineering computational solutions that are kind of more generally applicable, which is what they see as the mandate of computer science. And from the grounded perspective, dealing with real world messy problems means being intimately familiar with the particular domain questions and data provenance. So the second quote here is from a participant in the Data Science for Social Good program. And they're arguing that the very thing that makes data science a science is the process of coming to understand the context of the data. And there's a little bit more to this quote than what I fit on this slide. So it starts, there's a lot of context that goes into it too. And we've had a lot of workshops and a lot of discussions about that too, where the context of the problem really plays a huge role. Just by looking at the data alone, you can make conclusions that aren't relevant or mean nothing or aren't necessarily true. Making into a science of actually looking at the context you're putting it in and thinking about what the problem really means makes the data actually, gives it a purpose really, and you can draw meaning and conclusions from it instead of just drawing conclusions that sound good. So from this perspective, data science can't be agnostic because you have to be intimately familiar with the particulars of the domain context. So in other words, data science isn't so much a transcendent approach that's applied from the top down as it's built from the ground up on messy idiosyncratic problems within the domains. And then recall that for Slota and co-authors, data science is characterized by emptiness and hunger and is continually reaching outside of itself and into the domains for inspiration and raw materials. And what they call data prospecting is the means by which data science finds new sources of nourishment. And among our research subjects, a sort of clear and unequivocal articulation of that appropriated perspective was really rare. But I do think that this quote kind of fits the bill. So this comes from someone in a senior leadership position at eScience with an advanced degree in computer science. And what they're doing in this quote is addressing the challenges of being a data scientist by comparing it with the experiences of people in their computer science community who work on the development of scientific software. So they say, from a research strategy perspective, as a grad student and beyond, there are a lot of people that spend a lot of time working with scientists and everyone else, and we sort of trade war stories. The risk is that you can spend a lot of time working with scientists and find out that what they really need is an off-the-shelf, number 3 on the menu solution that doesn't really require any computer science research. So you will have just spent 10 months determining that, and you may get nothing out of it. So while this person was explicitly referring to their computer science community, in the context of this interview, they were concerned about an analogous situation between data scientists and quote scientists. And so we can see that the appropriative aspect of data science is premised on it being something separate and apart from scientific domains with different goals and different reward structures. So data science and domains have kind of tidy and discrete roles to play here. The domain provides raw material in the form of data, while data science provides the tools to transform it. And the domains need data science to provide technical skills, and data science needs the domains to stay relevant and innovative. But on the other hand, many of our interviewees saw data science less as an entity that stood apart from scientific domains and appropriated their data, and more as a collaborative space for cross-fertilization between scientific domains. And I think that sentiment is rather colorfully expressed here in this quote by a biology postdoc in this case, who says, you let the astronomers come up with new image analysis techniques because that's what they do all the time. And then you apply it to your data. There's no reason we shouldn't be going dumpster diving in their fields to take things we can apply to biology and other domain sciences. I see the things that you could do by combining multiple fields as the thing that's very exciting. And we call it data science, and that's cool. That's great. So while this person in some ways uses language that does have appropriative undertones like dumpster diving and opportunistically, the distinction we're trying to make here is that they're not claiming data science as something apart with an appropriative relationship of the domains, but rather they're thinking of data science as arising from the transfer of methods from one scientific field to another. So it's not data science reaching into the domains to satiate its hunger for data. it's a domain with an interesting data problem reaching across to other fields to advance its own methods and technologies. So it's an emergent space where scientists from different fields can learn and speak the same language. And it didn't fit on this slide. Well, actually, I guess it would have, because I ended up deleting something else. But this interviewee went on to say, I just need to be able to have a common language with which I can describe the problem to those people and then form collaborations with them. And that's awesome. And that emphasis on collaboration was echoed in the second quote here from someone who participated in eScience's incubator program, who said, I can't separate data science out from the concept of social learning, because to me, every experience I've had with data science has been about collaboration. So that's something I thrive on. I think of data science and I think of collaborating on projects. That's part of data science. So from the relational perspective, data science doesn't exist apart from the domains and extract from them, but rather emerges from collaborations between the domains. And now I will say, in the work of Rebus and Slota that we've been citing and their co-authors, they do say that data science either exists apart from the domains or exists between them and intermediates their relationship. But what we're trying to say here is that those are actually two different ways of thinking about data science, and we think that that's an important distinction with different implications. Okay, finally, according to an impositional perspective of data science, tools supersede both questions and data in the advancement of scientific knowledge. And I'm using tools here as sort of an actors category in the way that my research subjects would use it. So tools in data science are really a composite of method and technology that can't really be extracted from one another. And the impositional perspective says that data science orders the domains by rendering their data and questions legible to particular data scientific approaches to things like scaling and automation and extensibility. And I think that perspective is kind of implicit in this quote here by a researcher in the geosciences who had recently joined the eScience Institute at the time. And when asked what data science means, they responded, I'm coming to this field a bit new. I'll give you what I know so far, which is ways of learning about the world purely by looking at the data. I come from a background of hypothesis-driven science, whereas data science, the approach is to collect as much information as you can and use some of these newer technologies to actually let our knowledge of these systems fall out of the data themselves. So in this telling, as long as the data are compatible with the tools of data science, then knowledge just kind of poof, appears. But we also heard people talk about data science and also watched them work in ways that kind of invert that impositional perspective and instead portray data science as being about adaptation and creativity rather than conformity to an a priori form. So this incubator participant said, I'm not trying to diminish a tool, the contribution of the data science part of the project. I personally don't think it's an important factor in the conceptual design of a question or how you answer a question. I really think it's more about building the tool to implement the ideas and the questions that come out of the domain science. I can't generalize because what I had done for this is so specific. Those working on a different project might be completely different depending on what the data is. So rather than data science being about ordering data and questions across knowledge domains to be legible to the tools of data science, here it's about having these artisanal skills to create a bespoke assemblage that's totally idiosyncratic to your data in question. That might require working in multiple programming languages, importing various libraries, designing database structures, developing a pipeline for working across local and distributed machines, and somehow stitching all of those things together into a functional whole. So while all of these separate various tools certainly exist already, the researcher creates something new and unique that's specific to their work and emerges from the needs of their data and questions. So just to recap, the Transcendent View sees data science as being agnostic to context and applicable to domain questions kind of from the top down, whereas the Grounded View sees data science as being built from the ground up on the problems of domains. The Appropriative View sees data science as existing apart from the domains and exploiting them for its own advancement, whereas the relational view sees data science as emerging from collaboration between the domains. And the impositional perspective sees data science as ordering the domains by rendering domain questions and data compatible with the tools and approaches of data science. But the adaptive perspective sees data science as requiring an artisanal skill set to build bespoke assemblages of methods and technologies that are unique to a particular research question and data set. Now, these two different perspectives that we've outlined coexist even just within our one field site, and they're not even necessarily mutually exclusive of one another. So people sometimes express both perspectives at the same time. And so the question becomes then, why is that, and what's the consequentiality of it? So James and I have found it helpful to think about the way Deleuze and Guattari have theorized what they call royal science and nomad science. So they suggest that there are two formally different conceptions of science, and they use the terms royal science and major science kind of interchangeably to describe one of those conceptions, and then the terms nomad science or minor science to describe the other. But for the sake of consistency, I'm just going to stick with royal science versus nomad science here. So at the broadest level, the royal versus nomadic distinction refers to two different modes of intellectual inquiry or practice. So in philosophical terms, royal science is focused on being, and nomadic science is focused on becoming. And Deleuze and Guattari were, in a way, responding to what they saw as historical bias in thought toward being, or thinking of the world in terms of universality and static structures and fixed identities. And they argued instead for more emphasis on ways of thinking that privilege becoming, or fluidity, or processes of change and evolution and heterogeneity. So royal science thinks in terms of being. It's concerned with these static structures or abstract theorems modeling what they call a fixed essence. And it's geared towards producing constructs with universal applications. It relies on established ways of doing and knowing that makes its objects of study conform to precedents. And so it's concerned with the reproduction and reiteration of knowledge. In terms of matter and form, royal science privileges form. So it homogenizes matter to fit into specified theoretical models. Nomad science, on the other hand, thinks in terms of becoming. So rather than theorems, it's concerned with problems encountered in the world. In contrast to royal science's focus on universality, minor science or nomad science is interested in, quote, operations in which each figure designates an event. So this means that nomad science attends to concrete details of unique events that occur in particular contexts. So it's focused on the heterogeneous, the unique, the particular, and on aberrations and deviations. Nomad science doesn't aim to impose a particular form on matter, but instead adopts a practice of what Deleuze and Guattari would call following the flow of matter, so as to discover its singularities. And so we're suggesting that the royal nomad distinction provides a way of schematizing the two contrasting visions of data science that we discussed earlier and that emerged from our corpus of interviews. So we can think of the transcendent, appropriative, impositional perspective as an instantiation of royal data science, and the grounded, relational, adaptive perspective as an instantiation of nomad science. Now, according to Deleuze and Guattari, royal and nomad science are connected, and each draws on the products of the other. So nomad science discovers new problems, and by subverting established norms, continually cuts the contents of royal science loose. However, royal science continually appropriates the contents of vague or nomad science. Nomad science raises problems which are then taken up by royal science. So in sum, while the royal or major sciences operate within and strengthen existing knowledge and states of affairs, the nomad or minor sciences provide creative potentials for exploring new pathways and territories. So I want to end with just a few provocations here, some things that we can maybe think about and discuss in the Q&A. These are things that we'd love to hear your thoughts on, because we're kind of currently grappling with them as we build out the conclusions to the paper. And so I realize it's kind of subverting the Q&A to be presenting the audience with questions. And we're definitely happy to answer your questions as well. But we also would be interested in hearing your perspectives, especially because I don't really know very much about how data science is unfolding in Australia, or really anywhere outside the US. And when you're an ethnographer, it's kind of hard to stop being one. So you kind of go into every experience with that hat on, trying to learn new things and get people's perspective on things. So if any of these strike your fancy, we'd be happy to discuss them or talk about anything else. So one question we have is, are the two visions of data science that we presented in contest with each other, or do they complement each other in the way that Deleuze and Guattari theorized that royal and nomad science need each other? And is it kind of a moment in time that these two things coexist and one will sort of win out over the other, or is it a permanent state to have both of these visions kind of coexisting and perhaps feeding off of each other? Another question we have is, what does the existence of these two perspectives mean for the institutionalization of data science? For example, there are currently debates about whether data science is a discipline, or whether it's inherently interdisciplinary, or whether it's transdisciplinary. And all of those options, I think, have different implications for how data science should or will be materialized within the academy. So whether it's, we end up with departments of data science, or divisions that subsume other departments, or non-departmental research institutes and centers. Another question is, in our data, I don't know if this came through when I was talking. I tried to give you a little bit of background on each of the individuals who provided quotes, but we tended to hear the universalizing perspective more from senior scholars and people in leadership positions within the data science community. And the Nomad vision was articulated more often by people who were more junior researchers and folks who were kind of launching their careers. So what does that mean, and how important is that, is another question we're thinking through. And then finally, how does our analysis of data science for science within the academy compare to the way data science is practiced in industry? So those are all things we're still thinking about. I don't know if any of those questions are interesting to you, but we're also happy to take any questions that you all have about the presentation or the work, or anything else related to data science. And James, maybe you can jump turn your mic on and your video if you are willing to.
Yes, I'm here.
Okay.
Great, thank you so much. So the floor is open if anybody wants to chime in, or if you're, if you want to, Andrew, for example, I'm happy to read the what you've just typed in there.
That was kind of an internal sort of observation more than anything else for the ethnography brains. But I had a direct question, which was, you haven't used the word trust at all in your presentation. And we find that, well, a thing that comes up a lot in terms of the interaction between data scientists and their collaborators is trust, and trust around sharing data, trust building, et cetera, et cetera. Where does that, and I guess your parasitic versus collaborative observations sort of lean to that as well. Did the word trust come up in your field data at all, or is it a sort of a concept that's too hard, I guess?
No, that's a really interesting question. It does, and I would say that it comes up more so most of what I focused on here were kind of collaborations between academic researchers, but I also have observed a lot of projects that are academics collaborating with actors and organizations from other sectors. So government agencies, even private industry, nonprofits, things like that. And I think that issues of trust come up a lot more in those situations than between academic, one academic researcher to another. And so, for example, there was a project I was observing for a while that was, I was looking at one aspect of it, but it was part of a broader effort to build like a trusted data collaborative that would house, eventually the idea was to bring together transportation data from all different agencies and sectors, including private transportation providers like Uber and Lyft and things like that. And so the issue of trust was a major complicating factor. And I don't believe that ever got off the ground because the actors couldn't kind of overcome those differences. So I found it to be more salient in those cross-sector collaborations personally.
Would it be the case also that trust is incredibly important because it's not really a discipline, and so it doesn't have disciplinary norms and standards that are widely agreed upon? And so because of that, there's not like a data science ethics board of approval or whatever it might be, kind of institutional regulatory mechanisms that are stand-ins for interpersonal trust. Or not stand-ins, I guess, but kind of co-opt that so that it's not, like in psychology, for example, if you want to conduct studies on human subjects, it's not about trust at all, really. It's because there's this regulatory device that that universities have and governments and journals even require now, because people couldn't be trusted in some cases. And so maybe that's relevant to the extent that trust is really important now. It's because what is data science?
Right. Yeah, absolutely. And I think that, here in the US, at least, just maybe it was last year or 2 years ago, there was a revisiting of the Common Rule, which is the federal regulation that kind of dictates how research institutions then govern their institutional review boards that are responsible for overseeing research ethics. And I feel like it was a really missed opportunity to, seriously grapple with the implications of non-traditional data sources or data sources that have to do with people, but are not considered, the people they represent are not considered to be human subjects because they're not enrolled in research, because there's no interaction with them. And so, yeah, I think you're right. We're in this stage where it's kind of like anything goes, and people are trying to figure out what the norms are and what the guidelines should be and what the practices should be, for sure.
And in a slightly different context, in some of my previous research, which has been more focused on data science and in industry, I spoke to quite a few working data scientists in industry who use terms like, I only work with non-yucky data and other things like where trust issues wouldn't arise in the first place.
What they mean by yucky and non-yucky?
Like the guy who used non-yucky specifically was talking about like that he was really happy to be working with logistics data, like shipping containers, and he felt like it didn't involve surveillance. I think probably surveillance was probably the main. He didn't say it, but that would be my guess.
Right.
Like non-creepy.
Non-creepy, yeah. I guess probably similar to how creepy gets used.
Yeah.
right? Something that doesn't require a surveillance policy. I mean, privacy policy, my bad. Mar, do you have a question?
Not really a question. Sorry, more like a comment. So Anissa, just for background, I'm also in the Melbourne Data Analytics platform. So I agree with Andrew. I think we take a very nomadic type of approach to data science. So it's a group of about 17 people from all disciplines who have computational expertise, and we work collaboratively with researchers across all the domains to, they bring the research question and the domain expertise, and then we kind of bring the data science methods and tools, or mathematical and computational tools. And I gave a presentation as part of Researcher Connect a few weeks ago, where I talked about interdisciplinary collaborations. And I mentioned something kind of on passing as one of the take-home messages of respect, being able to respect different areas of expertise, how important that was for interdisciplinary collaboration. And that resonated with a lot of people, as well as the recognition of more non-traditional research outputs, I guess. Because when you're doing collaborative work in data science, it's not often that you actually get to a publication or things like that. It's more developing kind of new methods or automating processes. And I was just wondering if you had any thoughts or comments on those two things.
Yeah, absolutely. And I actually think that data science is its emergence has been interesting because there is this level of kind of introspection and reflexivity that data scientists are engaged in, and thinking about like what kind of expertise is necessary to do the work. And I mean, the kind of conversations that I see unfolding in places like the Harvard Data Science Review, for example, are just amazing. And there is this kind of big tent mentality that we need all kinds of expertise, including qualitative expertise, to be at the table and to be valued. And it's something that, I think Mike mentioned at the beginning that I'm involved with running this Data Science for Social Good program now, which I started off studying as, one of my kind of field sites, but then, and I kind of was always involved in kind of scaffolding conversations around ethics and stakeholder engagement and things like that. But I'm now sort of fully involved in leading that program. And it's it's interesting because I think on the one hand, there is this recognition that all these different kinds of expertise are important and need to be brought to bear on the problem. And yet there's still this like residual resentment of the time that needs to be spent on things that people kind of will sometimes reduce to like just talking. It's like they realize, oh, we can't just do this work without going out and talking to the stakeholders. We can't do this work without spending the time to investigate the data's provenance. We can't do this work without debating the ethical issues in the work. And yet they see all of that work, and it is work that they're doing, as tangential to or orthogonal to the work of data science. And so there's this tension there where people want to value it, but our incentive structures are so deeply entrenched in our practices that it's like, but I don't feel like I'm getting closer to the thing that's going to be recognized as a contribution, And so what we've tried to start doing is really like reframe those kinds of that kind of labor as part of the research process, and it's really challenging, but we introduce it as, when we expect you to be going out and communicating with stakeholders, we introduce it as part of as a qualitative research methodology that you're doing, not as just like a side conversation that you need to have, but something that is going to be systematically reflected upon and integrated back into your work. And so we've like even created a role in the program for someone that we call a human-centered data scientist, who is the person helping the teams kind of scaffold and do that work and really think of it as part of the research process. Thanks for that question. It looks like David has.
Yeah. Can I just jump in with a
go for it.
Question? So thanks. All the very interesting perspectives. But I was thinking, particularly with my background, that in all the royal science versus nomad science and all those different perspectives and parasite and all that kind of thing. Essentially, those issues have been the same for the best part of 100 years in statistics and all that kind of thing. I'm wondering if there's, obviously we've had the data explosion and explosion of new techniques and all that kind of thing, but those fundamental questions that you're asking, I don't think they've changed for decades, and it used to be organized as statistics, and there've always been these debates about where the academic home is, sometimes in economics and sometimes in mathematics and everywhere, because of the, many of the issues you've been discussing. So I wonder if you had any thoughts about that, is there something fundamentally new other than the new techniques?
Yeah. Actually, James, I'm gonna give you a first pass at this, because I know you've been doing so much reading on statistics and cybernetics and thinking about what parallels there might be and whether there's not. So do you have thoughts on that?
Yeah, and I don't have a satisfying answer for sure, but I can just tell you what line of thought has been, and it's been so it's interesting to see what data science gets compared to in literature by practitioners or people analyzing it like from the outside, like we are. But two of the things we've zeroed in, well, three. I guess there's three things we've been thinking about. One is obviously statistics, one is cybernetics, and another one is the particular job of the webmaster in the 1990s. And all of those three things sort of had quite different fates, right? I mean, statistics became a legitimate discipline. It's a well-established thing after being sort of debated for its whole existence, for a couple hundred years or whatever. And cybernetics was backed by powerful governments and had this it was a huge phenomenon in mid 1900s, and then it doesn't exist, more or less, right? As a discipline, it just vaporized completely. And of course, no one really hires webmasters anymore either, because the functions that are required for a modern website now are so diverse and specialized that one person doesn't generally do them anymore. So what I can say is that I guess that our question is sort of like future, the so what of this may be something about like the future, or thinking about the future of data science, like which way could it go?
Yeah, so I guess one way to think about your question then is like, yes, I think you're right. Like, that nothing new is under the sun, right? That these tensions probably have existed with the emergence of every field, and yet fields go in different directions, like James was saying. So will like I think the point of Deleuze and Guattari is that this royal nomadic versions of science always coexist, and they probably and especially at the sort of outset of the development of a field, but the fields don't all end up in the same place. So yes, it's a common tension, but what are the particulars that are going to make a difference in the future of data science, and how is that going to impact academia? I think are the questions that we really want to puzzle through in the conclusions of this paper. So it's an excellent question.
Can I ask, sorry, David, if you have a follow-up?
No, thanks.
Okay. One of the things, drawing analogy to this kind of most recent case of statistics, I don't know how exactly helpful that is, because kind of the institutional and social matrix or whatever that that statistics arrived in, it's very different, growing out of eugenics movements and a variety of other kind of turn of the century phenomena. But to the extent that it is relevant, I mean, one of the interesting things in my view about statistics and its emergence as a discipline is that it had to be disciplined. And so, that's kind of what allowed it to be more nomadic, to the extent that there was a coherent style of statistical theory that developed, and that came about through the work of the Pearsons, father and son, I guess, but Ronald Fisher, obviously, and then and Jerzy Neyman and a bunch of other people in that. And so then for statistics to be applied, like as a technology, in kind of a disciplinary fashion. What allowed it to be useful for any context, for any problem, is that problems could then be put into the language of stats and its underlying theory, rather than kind of the reverse, I guess. So its source of legitimacy was the underlying statistical theory, as opposed to the context of application and the person doing that. So, like if you look at, like the Gauss-Laplace synthesis and a lot of those kind of earlier developments in statistics that really are foundational, the central limit theorem, for example, that was really helpful, but that didn't allow it to just be applied to everything. You had to really, I think, on a case-by-case basis, argue why that was relevant. Argue why, for example, you should have some number of jurors, and that specific number, at least in France, there was a probabilistic argument that was brought to bear on that, and so things like that. But you really had to do a lot of reasoning and justification for that. Whereas after about 40, 50, maybe 60, certainly after 1960, you could just say, well, here's a statistical method, and it's valid because it's a statistical method, and irrespective of where you tried to apply it. And maybe that allowed it to be more nomadic to some extent, in a weird way, because it was exportable and could be justified based on its own logic, rather than having to draw legitimacy from more. I don't know. What do you think about that? Is that relevant here?
Yeah, that's really interesting. I don't know if this is what you're trying to say. One of the things I kind of was taking from that is that possibly, if we're thinking about like the possible futures, and like, will data science go the way of statistics or cybernetics or like the webmaster, that perhaps one of the things that allowed statistics to stabilize into a discipline that has its own identity, and yet also statistical methods are used in every possible domain, pretty much, is having coherent principles and theorems. And so that both of those things coexisted. And I wonder if one of the things that currently is true about data science is that it doesn't have those core, a coherent core of theories and principles. And so maybe it can only be nomadic for a while, but is this just a moment in time? And like these other fields, it will take decades for that to emerge, or will it just kind of continue being this sort of interdisciplinary non-space? That's just where my head went based on what you were saying.
Right. I mean, what would that even look like for data science if it's not? I mean, statistical theory, there are proofs, there are, for various things. Yeah, I don't even know what that would look like for data science.
Yeah, don't know either.
And nor could one predict, I guess, probably, or else it would have arrived already.
and having like a central core theory does not necessarily mean that it will discipline up, because cybernetics had a very well-defined basic set of principles, right? Like circular causality or whatever you want to call it. But so obviously that's not the only factor.
Right. And it could even be ethical, for example, like whatever the principles are, they don't have to be computational. They don't have to necessarily be mathematical. It could be, we identify with being data scientists and we conduct ourselves in specific ways, and we're legitimate in our practices wherever we go, because here's our code of ethics, and here's our society that's got 200,000 members across the globe, and we have annual meetings, and we've got a journal, and we've, it doesn't even have to be about theorems or methods necessarily. That could cause it to kind of cohere and become.
Yeah,
good point.
That's a really interesting point.
I don't know. Okay. This is so cool. Does anyone have anything else, or Anissa or James, did you want to?
No, thanks.
Say or do anything else?
No, I think I'm gonna have to relieve my mom of baby watching duty soon.
Okay.
So.
Okay, but this is great. This is perfect. I think people are quiet now because they're going, yeah, I'm gonna have to give that more thought, rather than we've run out of questions or ideas.
Yeah.
So that's exactly where a good academic talk should stop. So I'm going to need to think about that. Thank you so much for,
Oh yeah, I just want to put our email addresses up if anybody does want to get in touch, continue the conversation. This was, we really enjoyed the wonderful comments and questions, and it really gives us some food for thought that'll help us get this work to the finish line. We appreciate it.
Definitely.
yeah, thank you so much for doing this, and best of luck with your project. It's already really cool. Look forward to reading it in print soon.
Thanks a lot.
Thanks.
Thank you.
Bye, everyone.
Bye.
Bye, everyone.